So that brings us to section 3, right? That sex differences are real if they're biological, right? So now we're going to be turning to the body, right? Because we find that a lot of the cultural differences, they vary across cultures, they vary across time periods, so they're not stable, they're not consistent, so they don't meet that benchmark or they don't meet the author's benchmark for realness. But what about if we turn to biology? So when we're talking about biological differences, and here they're looking specifically at biological differences as it relates to hormones, genetics, and brain morphology. So beginning first with genes. So they talk about that, a gene, these are the, set of instructions for building and maintaining our bodies, right? So we all have our own unique genetic code, and it's unique to us, and that's our genotype. And how that genotype is expressed, what's observable, what's visible, we call that our phenotype. So genotype, your actual genes, phenotype, how they are then expressed in terms of your looks as well as your behaviors. And so your book notes that there are differences in the genetic contribution of the X and Y chromosomes. So one interesting fun fact that comes out of this chapter is that most of our kind of genetic material is carried on X chromosomes. And really, they say that, now that we've broken, we have cracked the genetic code, we know that in terms of the material that's carried on the Y, that it's actually not a lot. It gives boy fetuses functioning testes and adult males. It helps facilitate male fertility, but beyond kind of that basic sex difference, the only other characteristics that's carried on the Y chromosome is apparently hairy ears, which is why I guess, men have hairy ears, and for the most part, you don't see, although women have, hair plenty of other places, you don't see a lot of hairy eared women because, no Y chromosome. So what else is going on there in terms of those genetic differences? So they talk about, 3 ways that genetics can contribute to gender difference. They talk about the fact that some traits are what they call sex linked, some traits are what they call sex limited, and some traits are what they call sex influenced. All right, so I'm going to work my way up. So let's talk about sex influenced first. So sex influenced is the type of genetic difference where it only occurs in the presence of some other characteristic. So for instance, baldness, for instance, although the baldness gene can be carried by men and women, it usually is influenced by having a high level of testosterone. And most women do not have a high enough level of testosterone to trigger that gene from expressing itself. So the baldness gene, while it might be carried in a woman, is less likely to be expressed. And so that's what we mean by sex influenced. And so they say, interestingly enough, similarly, high versus low voices, gene that once again is influenced by the presence of certain sexual hormones, right? So, in women, it makes their voices high, and in men, it gives them, lower voices. So that's sex influenced. Then we have sex limited. So these are genes that literally only get expressed in a male or female body. And the example your book gives you is basically milk production, which allows women to breastfeed. So that gene, which both men and women have, it only uh, it only is active if it is then in a female body. So that's what's meant by sex limited. And sometimes students are like, well, how is that different than sex influenced? Because sex influence, there are women who experience baldness, and usually those are women that have higher level amounts of testosterone, right? So just, kind of recall that when we were talking about, what makes someone a male versus a female bodied person, that there are kind of anomalies that happen, that there isn't always this perfect correlation between, you have sex hormones and you have the corresponding genitalia and you have the corresponding chromosomes, that sometimes there can be these different pathways and these anomalies, mutations that kind of branch off. And so in this case, like something like baldness, if a woman happens to have a higher level of testosterone, then it doesn't matter that she is a female body, the baldness will occur. While something like sex limited really is limited to someone having really all of those corresponding sexual traits, characteristics, hormones, and chromosomes. And now maybe kind of the most involved one is sex linked. And so your book goes very deeply into detail about the fact that, because women have two X's and men have just one X, and as we've already said, most of our genetic material is carried on an X, that means that if something is recessive, like color blindness, men are going to be more likely to experience it because all they need is that one, that one X. So, they could get, if their mother is recessive, and this is kind of what that image is trying to depict there. If you have a carrier mother, that, whether or not she gives a non-affected X or an affected X to her son, kind of is going to determine whether or not he gets that recessive trait. While her daughter literally is going to not have it, because the daughter, if the father is unaffected, is going to get an X from her father that doesn't carry the trait, and so it doesn't matter which X she gets from her mother, and so this is why we see color blindness in much greater proportions among men than among women. So for people that love genetics and biology, you probably know a lot more about this than me. I admit I find it interesting, but I'm fairly limited in my knowledge about it, beyond the basics, what you read here in the book. So if anyone has some better examples or interesting information, you would like to share it, feel free to shoot that to me. Otherwise, going back to our other biological sources of biological difference. So one other source is hormones. Once again, we talked about this in a previous chapter, that all human hormones circulate in both men's and women's bodies, but they do so in different proportions, right? Men tend to have more testosterone, women tend to have more estrogen. And so particularly testosterone has been a focus of research. So what is it about testosterone? It's been shown to be related to things like sex drive, aggression, visual spatial ability. And we know that for young men, it's responsible for sex differentiation at two of the most kind of critical points in their lives. It distinguishes the XY fetus into a male fetus between weeks 7 and 12 during fetal development. This is called the testosterone bath. So there's like a wave of testosterone that the male-bodied fetus receives, and this is what allows or begins, the genitalia differentiation, right? Is why, at some point towards the end of that first trimester, the doctor can tell if you're having a male or female infant because that testosterone bath has taken place. And then there is a influx of testosterone in male bodies during puberty, right? And this is why we start to see some of the development of those secondary sex characteristics. Taller, broader shoulders, more hair, deeper voice, all of that's kind of related to that second wave of testosterone. But throughout men's lives and females' lives, but particularly men's lives, testosterone, their level of free testosterone in their body can change, can vary. And so, the level of testosterone that a man has in his body at any given moment, it isn't stable. Your book makes that point that we often talk about hormonal fluctuations that exist in women, but hormonal fluctuations also exist in men. And although and just in general, the level of testosterone that men have varies within the population, just like with women, right? So on average, men have more testosterone than women. They have more because they have more free testosterone in their system. But certainly there are some women that have higher testosterone, and they can overlap with men that are have particularly low testosterone. So this is why you don't want to think about it as an all or nothing, males have this, females have this type of situation. And so it leads to, in what situations, does testosterone influence behavior, right? That's kind of been a big question. And certainly research seems to suggest that there is what we call a bidirectional relationship between testosterone and aggression, meaning that, you do something aggressive, like get in a fight. If you win that fight, it actually causes you to have more testosterone, which perhaps contribute to you being more likely to get into another fight. And so it becomes kind of a cycle. And you can maybe certainly see this with people that participate in violent sports. Some of the difficulties that they might have turning that behavior off once they leave the field or the rink. I'm thinking about like football and hockey in particular. That type of violence that can happen within the sport oftentimes spills over into their day-to-day lives, their relationships, their interactions with other people. And it is at least maybe partially because of this bidirectional relationship between testosterone and aggression. But then there's also this placebo effect of testosterone, right? Because once again, these cultural stereotypes matter. So what we tell ourselves and what we tell people about testosterone also gets in people's heads. So, it's been shown that, just telling someone like, oh yes, I'm giving you, testosterone, take this testosterone pill, or like, oh yes, you have high testosterone, even if they really don't, even if it's just a sugar pill, it then makes them more likely to engage in this aggressive behavior because of what people think they know about testosterone. And so once again, it brings up that whole very tricky, if we can manipulate it so easily, is it in fact a real difference? And so, as I kind of said, before I leave the topic of testosterone alone, we do know it varies across men's lives. It varies between men of status. Men of higher social status tend to have higher levels of testosterone. Married men with families tend to have lower levels of testosterone. Girls who have androgenital syndrome have higher testosterone. Girls whose mothers took progestins during pregnancy have higher testosterone, while boys whose mother who took estrogen during pregnancy tend to have lower. So all of this is just shows that, once again, that this isn't kind of this perfect correlate that we think it is. And of course, as I indicated, some of the issues that we have with this research is how it can in fact be manipulated. And once again, how the fact that there is still this cultural element that, in our society where we say, oh, yes, it's boys being boys, or, oh, men are aggressive because of their testosterone, is still just worth noting that if we look at other cultures, right, if we look at that cultural variation, although aggression, men are more likely to be aggressive than women in most societies, the size of that difference does vary. And it varies in such a way that it can't be because it can't be explained by testosterone, right? Men in all societies have this variable amount of testosterone that is, in most cases, higher than the women in societies. But in some societies, like the United States, men's reported levels of aggression, their participation in violent crimes is much higher than men in other societies. So, once again, it just suggests that biology isn't the only kind of underpinning, it isn't the only explanation of what's going on. The final kind of potential biological source of difference is brains. So a big question of brain organization theory is how are male and female brains different? And they are different. There, and your book does note there are these differences in size, in shape, in composition, and even in function, like rate of blood flow, how quickly the brain metabolizes glucose, neurotransmitter levels. And I'm just taking the book's word for it because, once again, let me remind you all, not a STEM major, but there are these differences. But there are kind of two things that kind of complicate, the importance of this. One issue is, there's been a lack of research that has conclusively shown that these differences actually matter, in terms of behaviors and personalities, right? We haven't gotten the data to line up in that type of way. And it's made more complicated by the fact that most of us have what's called gender non-conforming brains. And so the author says this is actually like almost 98% of us. So, what does that mean? It means that if you're looking at all those possible ways in which male brains differ from female brains, most of us have brains that are some amalgamation of male and female in terms of its characteristics, right? Size, composition, functionality. So although it might make for a cute movie, in 2018, the movie The Female Brain came out, it scientifically is just not that clear cut. And then it becomes even less clear cut when we start looking at the relationship between hormones and brains and gender difference. Because, that is my dog. So my apologies, that was my dog. So he got kicked out of the room here. I think I was at the point where I was talking about the relationship between hormones, brains, and gender difference. So, your book just kind of talks about how this has been just really complicated. And, once again, the one hypothesis that your book goes over is that our brains, our bodies perhaps evolved in order to enable sexual difference for purposes of reproduction, but also to compensate for any maladaptive differences that arise as a consequence of building male and female bodied people. And all of this, I think, is a complicated way of just saying we really are set up to be as similar as possible. And so, once again, we are just creatures that have very low sexual dimorphism. So one example that your book explicitly kind of, talks about in terms of, difference in brain functioning has to do with mental rotation. And so, the mental rotation test, can you look at figures that have been rotated and determine are they the same figure or not? And what they found is that when it comes to mental rotation, that there is a sex difference, that this is a medium size, and this was supported by Zale's study, but this is a medium size sex difference. And oftentimes, females were worse at this than males. But this is another example of something that, as it turns out, can be manipulated. It isn't stable. It is, in fact, mutable. So what they discovered is that they could diminish the size of that gap between males and females by basically requiring women to play Tetris. And they said, this study basically showed that if you assign women to a semester of playing Tetris, it pretty much closed the pre-existing gap between men's and women's scores. And that just even 10 hours of play reduced the difference to the point where it was no longer statistically significant. And so all of this just suggests, of course, that, biology isn't destiny, that, even if there are these perhaps built-in differences, sex differences in the brain, and we aren't sure to what extent, they are, to what extent they exist, but even the ones that we are aware of, like mental rotation, that conclusion, your brain is what you do with it, is an important one.